So I would like to introduce Sandhya. So you're joining us all the way from Chicago. And Sandhya is a machine learning engineer working for iManage. So over to you, Sandhya.
Right, let me share my screen. Can everyone see my screen? Right.
Yeah.
Hi everyone, I'm Sandhya, and tonight we'll be talking about Kubeflow and Pipelines. So it's going to be a quick introduction on what Kubeflow is and what kind of problems it's helping us to solve. So machine learning is everywhere, and when we think about machine learning, we're mostly as a data scientist, I think about data gathering. How do I pre-process the data? How do I explore? There's some exploration bit in the data, the training of the model, and then after retuning and hyperparameter tuning, I finally get a model, and that's kind of the world where a data scientist is mainly focusing on. But in reality, that training of the model, the machine learning model, is very important, but a very small part of the whole ecosystem of machine learning in production. There are a lot of components that needs to work together in order to make that machine learning model into a product and actually make it live, really. So some of the key problems that a data science teams have these days is are following. So how do we interface between the engineering and data science expertise? So at times, for example, a data scientist would be working in silos, in a separate environment, completely different from production. So how a data scientist and a software engineer can work together to have a painless model delivery. So here really we're talking about having a dev server and a service or a production system as similar as possible. How do we ensure engineering best practices for the machine learning code? So how do we test our machine learning code and have the full test coverage? How do we ensure the CI/CD around it? So for example, if one of the component in your machine learning pipeline changes, so for example, if a data changes or a parameters changes, how do you go about updating that model in your production? So these are all the big questions that we think about. And finally, how to build processes around storing the outcomes of the experiments. So this deals with, once you train a model, what happens to the artifacts that are output from that model? So where do you store it? Is it your central place? Where do they live? And how do you really report the performance of your machine learning models? So these are all the big questions that currently data science teams are dealing with. And that's where really Kubeflow shines and comes to the rescue. It's a framework that is that kind of makes machine learning standard in your. It makes a machine learning deployment. It standardizes machine learning deployment and production. Let's say. It's a framework with a set of compatible tools, all geared towards your machine learning that lays the foundation of your applications and production. So Kubeflow pipeline is one of them that we'll talk about more, but then there's a Catip, for example, that deals with automated hyperparameter search for your models. There's a Jupyter notebook for people who are not who wants to keep the same environment for data scientists, but yet they still work with in the microservice level. There's an Argo that deals with the CI/CD pipelines that works really well with the Kubeflow. So Kubeflow kind of creates a whole ecosystem for your machine learning and gives it an end-to-end solution for your machine learning model at the enterprise level. Some more things about Kubeflow. It's an open source framework, which was built by Google, and it's built on top of Kubernetes. So it extends all the functionalities of Kubernetes itself. It transforms the way a machine learning experiment is performed. So that means before an experiment may live on the machine of a data scientist and the Jupyter notebook, and all those are locally very specific to that data scientist. But Kubeflow kind of provides you a unified tool where those experiments are shareable and reproducible. it helps data scientists to focus on things where their skills are needed the most. So once you have Kubeflow in your system and when it's up, it makes it really easy to perform those machine learning experiments. And what it allows you to do is really focus your energy on the task where your human skills are needed. So Kubeflow can can take care of your automated training, let's say, for your models. So allowing all these, it accelerates the path to delivery of your machine learning models. So because everything runs on Kubernetes and in a way microservice level, what happens is you don't have discrepancies over your dev system and your production system. So it allows you, so there's no friction, there's no wall between there is, but very less amount of friction between making your machine learning model into production. So it helps that way. So I'll be talking about Kubeflow pipelines out of all the tools that Kubeflow provides. It's a core component of Kubeflow for building and managing machine learning workflows. So a pipeline refers to a single workflow which comprises of different components, right? So think of a pipeline as your training job for your model. And each component is a step in pipeline. So really, usually, what we do is we do have steps in pipeline. We just don't think about those as a separate components. So data loading is a separate component. Pre-processing is a separate component or a step in your pipeline. And because pipeline is an abstract term and it kind of combines all these components together, a run would be an execution of the pipeline, and it will get more clear what exactly it means. So what exactly a pipeline component is and what it comprises of. So a single component would be a Docker image. It will have its functional code. So for example, let's talk about pre-processing. Pre-processing is a single component. It will have its own Docker image and a functional code, which is actually doing the pre-processing on your data, let's say, and the client code that actually communicates with your KFP, the Kubeflow Pipeline SDK. And the client code, it lets you integrate your Docker image into the pipeline. So if you look at this code bit, each component it looks like it's kind of function, right? Think of it as it has an input and some output parameters. So pipeline step, let's say, again, continuing with the pre-processing example, you have parameter 1 and 2, and think of them as you have data as a parameter and also a column on which you want to do the pre-processing on, right? Those will be the parameters to your Docker image. And then what it outputs is a pre-processed data. And so you can think of everything. So this is a Python code, right? So for example, in your pipeline, if you have 5 components, you will have 5 pieces of this chunk of code 5 times with 5 different Docker images, all talking to each other. But so the design of the code remains the same for each component. On high level, what happens is your Kubernetes, your cluster is running on, regardless, it can run anywhere. It can run on Google Cloud, AWS, Azure, or on-prem. You have a Kubernetes cluster installed, and then you have a Kubeflow installed on it. And this is a pipeline that is running on Kubeflow, right? So in your pipeline, you have 5 steps: data load, pre-process. And what happens is the output of the data load components becomes the input to the pre-process. So there's a lot of detail on how this link is created. It can be, there's a concept of persistent volumes. There's a data passing mechanism in Kubeflow embedding. We won't go into detail, but think of this as a graph, and all these components are connected to each other. And also can happen is that this one output can go into multiple components. So it gives you this flexibility around building your machine learning workflows. And so each component has a Docker image, and because it's running on Kubernetes, it really translates to a pod. So everything becomes a pod at a very lower level. And what you can do, extending the Kubernetes functionality, you can scale all those parts. So for example, a training job can be very resource extensive. So what you can do is you can give it more pods assigned to it so that it can does a job in parallel. So it has all these nice stuff around it. And finally, Kubeflow comes with a SDK, but also comes with a UI. And this is one of the snapshot from the Kubeflow UI. But what lets it do is that this pipeline file becomes a tarball, which you can upload on this UI, and it becomes a graph on the UI. And then, so what you can do is you can make runs on the pipeline. You can track the workflows and metadata. So Kubeflow has its own metadata component that lets you track the metrics and parameters and have the lineage of where these metrics are coming from. So somehow it has a CI/CD embedded in it. It can let you visualize the metrics. So for example, if you have ROC curves or confusion metrics, you can all have these all stuff on the UI itself. So you don't have to dig into the code and do all the plotting in the Jupyter, let's say. It can let you compare multiple runs of a training job. So what you can do is once you have, you can have multiple runs in parallel with different hyperparameters, but then you can compare across which run produced better results, which parameters are working for you and not. And then it has a nice versioning and logging system. So each pod has the logs, and you can build a system around like Elk and Grafana dashboards that lets you have the logs logged somewhere else. So it's a system that allows you and works really well with other platforms for your end-to-end machine learning workflows in production. So yeah, that would be me for today.